The image shown over here is of a fixed test bench. The fixed test bench has many disadvantages as the test points are not movable and this is only valid for a certain specific PCB. Each subsequent PCB needs to have a separate test bench. The fixed test bench is also strictly analog and can only check the values of signals going through the pins and cannot detect manufacturing errors presented. The next image shown over here is of the Gerber file of a universal test bench. It is an 8x8 matrix with a 0.1 inch resolution. It has 8 analog pins and 56 digital pins. Being a universal test bench, any PCB which conforms to these restrictions can be put on the test bench and can be tested for manufacturing errors as well as on load and off load conditions.
So I'm going to start with a general Gerber file, which is in the form of a text file. I saved it in a .php format. So this is how a general Gerber file looks like. There are two formats, RS247X or RS247D. Now I've developed a code. All this data in a Gerber file is in formatted form to save memory. So I've developed a C++ code in Microsoft Visual Studio, which gives me the extracted coordinates. And I will show you the code in short. So here's the text file of the code. Yeah, it's a pretty long code, so let's show you what it does. So over here, I taken my Gerber file, which I have to convert, and I convert it into a .csv format for Excel, so that I can read it as a spreadsheet with all the formatted data as output. So I created .csv file, and now it should be there in a folder. There it is. So now we have an Excel file in which I have all the formatting data, in which this Gerber file was formatted in the zero format, and the scale is in inches, and scaling is in absolute mode. And now we have all the coordinates, and we get to know if they're connected or not. Now what we'll do is we take this, we import this Excel file spreadsheet to Labview, and we extract all the coordinates so that we can use it for our universal PCB tester.
So let's start with the Labview program. We downloaded a library from Labview itself, which converts the Excel file to Labview. Let's select board.csv, and as we run it, the data will appear on the front panel. Now we can see that the data is appearing on the front panel. So let's see what we've done with the Arduino code. So let's look at the Labview Arduino code. So what we've done over here is, for the analog pins, we specified which analog pins you need to select, and depending on the analog pins, the multimeter will show how much voltage is going to be present. Now for reading the digital pins, we can see which ones are connected and which ones are not. So in the digital pin write option over here, we can specify which digital pin we need to check. And with respect to that, suppose we have a 2x2 board, we can see which one's connected and which is not connected by seeing the value 0, which is equivalent to ground, and 255, which is equivalent to high. We can even select the board over here, which we can see by selecting either Mega 2560 or the Uno. So thus we can check all the pins of the Arduino board and monitor the pins on the PCB as well.